Hello guys, welcome back to another video. In today's video, we'll be learning how to create a RAG AI agent that can read your resume and can answer your queries. So we'll be building an agent that can read your document, understand resumes, and answer questions like a human expert. Imagine you're uploading your resume and the AI can instantly tell your strengths, you suggest improvements, or answer interview style questions, all powered by cutting edge technologies like LangChain, Google Gemini, and much more. The aim of this video is not to just build a resume bot, but the real aim is to make you able to understand what RAG is, what RAG AI agent is, and to make you able to create your own RAG AI agents to boost your productivity and save time. So let us dive onto the video, and first of all, let us understand what is RAG, what are we going to do to create our RAG AI agent. So first of all, what is RAG? So RAG stands for Retrieval-Augmented Generation, and RAG is a technique in AI that combines two key components. First component is retrieval and second component is generation. So retrieval means finding relevant information from a knowledge base or document collection. In our case, the knowledge base is going to be resume, which is going to be in .txt format, and the second component of RAG is generation. So generation means using LLM to create responses based on that retrieved information. So overall, how your RAG works is that instead of relying solely on LLM training data, RAG first searches through external document or database to find relevant context for a given query. This retrieved information is then fed to your LLM along with the original question, which will allow it to generate more accurate, up-to-date, and contextually grounded responses. So let us see how we're going to build our AI agent. First of all, we'll have a resume, which will be in text format. So maybe there are 1000 texts in resume.txt. Now what we'll do is we'll create chunks. So maybe in one chunk, there will be 500 characters. So we build chunks from our resume.txt. We have separate chunks. Now what we do is we create embedding for each chunk. So embedding is just a numerical representation of text. So we have chunk, we create numerical representation of those chunks. And then what we do is we store these embeddings in a database, a special database, which is called vector database. And when we need to retrieve some information from the database, we use a special function called retriever, which we'll be building in our AI agent. And then after retrieving from database, we'll send those information to the LLM so that LLM can structure the response and display it to the user. So if you didn't understand this, I have made an example to make you understand how this workflow actually works. So first of all, we'll have a resume.txt where it's just a text format. Then what we'll do is we'll create separate chunks. So in this case, there is chunk 1 and chunk 2. Then what we do is we convert these chunks into numerical representation, which is called vector embedding. And then we store this vector embedding to the database, which is vector database. So this was part 1. Now in part 2, what we do is user will have some queries like what are my strengths. So maybe user want to know what his strengths is by looking at the resume. So what our AI agent will do is that it will create a vector embedding of the user query, and then it will go through the database, which is our vector database. So it will search every vector embedding and then it will find the closest match. So after it finds the closest match, it will convert those vector embeddings to text format. And then what we'll do is we'll pass the text to the LLM for structured response. And then LLM will give a display or it will give output. So this is going to be our workflow. Now let us come to our Visual Studio Code and let us actually code our AI agent. So okay, after opening my Visual Studio Code, what I have done is I've created a .env file where I have stored my API keys and other credentials. So to show you what the env file looks like, I've created an env.sample file. So you can see, first of all, we need Hugging Face API key. Second thing we need is Supabase URL. Then we need Supabase key, and then finally we need Gemini API key. So let us quickly see how we can get these API keys and URLs. So I open my Google Chrome. So to access the Hugging Face API key, you can click the link in the description and then you will land up in this page where you can create new token. So this was for Hugging Face API key. Now to access the Supabase URL and API key, you can again click one of the link in the description and then you will land up in Supabase dashboard where you can actually access API key and Supabase URL. Now again, to extract Google Gemini API key, you can click one of the link in the description and then you will land in this page where you can click this button, create API key, and then it will create an API key. You can come up to your Visual Studio Code and paste all those keys in these fields. So it is super simple. So now what we're going to do is we need to install some dependencies which we need to create our AI agent. So let us install our dependencies. So the first dependency we need is LangChain. So LangChain / community. The second thing we need is LangChain / core. And the third we need is Supabase, because Supabase is the database we'll be using as our vector database to store the embeddings. So Supabase / Supabase-js. And another thing we need to load our .env files is .env dependency. So this is all we need. So if you need more dependencies, we'll come and install it from the terminal. So for now, let us click enter and let us wait to install these dependencies. Okay, so took a little while to install these dependencies. One thing I noticed is that we haven't installed LangChain / Google Gemini because we'll be using Google Gemini as our LLM. So let us install that also. So npm I LangChain / Google Gemini, Google-Gen AI. So let us install this, and while this installs, let us create our index.js file where we'll be building our AI agent. So let me close this sidebar, and now let us code our AI agent. So first of all, okay, one thing we need is we need our knowledge base, and as I told you, our knowledge base is going to be where it is. Okay, our knowledge base is going to be .txt file, which is resume.txt. So now what I want to do is I want to create a resume.txt file and then store a resume there. So what I can do is to create a sample resume, I will open ChatGPT and I'll give a prompt to the ChatGPT to create a resume. So I have entered a prompt in the ChatGPT. So let us hit this prompt and let us copy the resume that it gives me. So okay, my ChatGPT has generated a 3 or 4 paragraph resume for me. Let me copy this resume, come to my Visual Studio Code, and then let me create a resume.txt file. So resume.txt, and let me paste the resume that ChatGPT generated for me. Let me save this file and close this. So this resume.txt is going to be my knowledge base. So now what I want to do is I want to extract the text from resume.txt. So let us create a new variable called resume text, and then what I want to do is I want to read file. So I need to import read file function. So let us come at the top and then import read file from fs/promises. Yes. So read file is a function where we need to we need to pass the path to our resume.txt. So resume.txt, and the format is UTF-8. So we also need to add await because it will take some time. So now let us console.log resume.txt and let us see if resume.txt is available or not. So let us save this, open our terminal. Let me also close this sidebar. Let me clear the terminal and hit node index.js, and we can see our resume.txt is console logged out in our terminal. So it is working. So now what we want to do is we have our resume text. Now what we want to do is the next step is after importing resume.txt, we need to create chunks. So let us move on to that. So to create chunks, we need a function called recursive character text splitter. So let us import that function. So import something from LangChain. So okay, we have to install LangChain. Looks like we haven't installed LangChain. So let us come to our terminal and let us install LangChain. So we need to install separate LangChain as well, because there are certain components that we need to use from LangChain. So let us wait until this installs. Okay, so LangChain has been installed. Let us come back to our index.js. Let us import our function, which is recursive character text splitter from LangChain. So the function is LangChain / text splitter. So text splitter, and the function we need to import is recursive character text splitter. So let us use this function. So actually this is not a function, this is a class. So let us create an object of this class. So recursive character text splitter, and we need to pass certain configurations. For example, what is going to be our chunk size? So let us keep our chunk size as 500. So this means that we want every chunk to have 500 characters, and we also need to pass chunk overlap. Let us set as 50. So we want our every chunks to have 50 characters from the previous chunk. That is what it means by chunk overlap. So now let us store the object in text splitter. Okay, splitter variable. Now let us create the chunks. Now to create chunks, we need to invoke this object, and we need to use a function called create documents, and then we need to pass our resume text in this. We can also pass several text in this array, but in this case we need to create chunks from resume text. So we are passing resume text in this array, and then let us store in the variable docs. So const docs. So let us console.log docs, and let's see how it looks like. So console.log docs. Let me save this, open my terminal, let me clear my terminal, and then node index.js. So okay, one thing, we need to put a wait here because it takes some time. So let us run node index.js in our terminal. We can see our separate chunks has been created, and chunks are made in the form of document. So this is the first chunk. This is the content of the first chunk. So every chunk has its own document, and it has base content, it has metadata, which has some useful information like from which line to which line the chunk was created, and there are several chunks that has been created. So looks okay, looks good till now. We have created chunks. Now what is the next step? So next step is creating embeddings. So let us create embeddings. So to create embeddings, what we need to do is we need to use Hugging Face. So as I told you, we'll be using Hugging Face to create embeddings. So let us import Hugging Face inference embeddings. So that is what we'll be needing to create embeddings. So import Hugging Face inference. Okay, this is not one we need. So import something from, so @langchain /community /embeddings/hf, and from this we need Hugging Face inference embeddings. So yes, so let us create a new instance of Hugging Face inference embeddings. So new Hugging Face inference embeddings, and here we need to pass several configurations like API key. So we have our API key in .env file. So in this file, so I have created a sample file. So I hope you have already pasted your API keys in this file. So now what we need to do is we need to provide our API key. So process.env.huggingface API key, and then we also need to pass the model that we'll be using. So model is sentence transformers /all mini. So okay, it's hyphen mini lm l6 and then the version 2. So this is going to be our model. So we have passed our API key. Now let us store this instance in a variable called embeddings. Okay, so now what we need to do is we need to create so we have created embeddings. So okay, first of all, let us check how these embeddings look like. So let us do console.log embeddings. So I think this should show an error because I think our file will not get access to Hugging Face API key because we haven't loaded our .env file. So what we need to do is we need to import load env file from process, and then we can do something like load env file. We can call this function. So now let us come to our terminal and we should see the embeddings. So let us clear our terminal. Let us run node index.js. Okay, there's a problem. So okay, our error says that it cannot find package Hugging Face /inference. So let us install that package. So npm I Hugging Face /inference. So let us install this dependency. So okay, we have installed our Hugging Face /inference dependency. Now let us clear the terminal and run node index.js. So we can see that embeddings has been created, but we cannot see it currently in our console, and that is all right. So we can assure that embeddings has been created and everything is correct till now. So now what we need to do is we need to create Supabase client, which we need to interact with the Supabase database. So to create Supabase client, we need create client function. So create client. So create client is a function from Supabase /supabase-js, and we need to pass our Supabase URL and Supabase key to this function. So process.env.supabase URL and then process.env.supabase key. So let us store this in the variable client. Now what we want to do is we want to store the embeddings in the Supabase. So to store the embeddings in the Supabase, we need to configure our Supabase database first of all. So let us come to our Supabase dashboard. So to do that, come to our new tab and then search for Supabase LangChain. I'll provide this link in the description box. So click on the first link, and here under SQL tab, you should be able to find a code which has already been provided by the LangChain Supabase docs. So what this code is doing is that it is creating an PG extension vector, and then it is creating a table called documents, and then a function which searches for the matching embeddings. So what we need to do is we need to copy this code, come to our Supabase SQL editor, paste this, but before running, we need to do one thing. So by default, this document is using OpenAI to create embeddings. But in our case, we are using Hugging Face to create embeddings. So if you come to our Google new tab and search for Hugging Face embedding dimensions, you can see that Hugging Face creates 384 dimensions, but OpenAI creates 1536 dimensions. So instead of 1536, we need to specify 384. So let us edit this 384. And under this match documents also we need to specify 384. Now let us run our SQL editor. So okay, I get an error called vector already exists, but you should be able to run this because you are setting up the first time. But in my case, I already did this previously, so I'm getting an error. So after running your SQL code, come to your side navbar, click table editor, and there you should be able to see your table. So we create a table named documents, and if you open this table, you can see that there are 4 columns. First is ID, content, metadata, and then embedding. So content is going to be a plain text, and then embedding will have vector embeddings. So now that we have set up our database, let us come back to our code and let us store our embeddings that we created here in the database. So let us first, to store the embeddings, what we need to do is we need to create Supabase vector store. So let us create a new instance of Supabase vector store. Supabase vector store. So we import Supabase vector store from langchain/community/vector stores/Supabase. So in this instance, what we need to pass is, first of all, we need to pass our embeddings. And then what we need to pass is our client, our table name. Our table name is documents. And then we need to pass our query name. In our case, the query name is match documents. So this should retrieve, so this should store all the embeddings in the database. So let us store this in the variable vector store. Now to retrieve the matching documents, what we need to do is we need to create a retriever. So let us write vector store, and then we need to use as retriever function. Let us store this in the variable retriever. Okay, retriever. So this retriever is used to retrieve the matching documents from the database. We haven't actually stored our embeddings in the database, and to store embeddings in the database, what we need to do is, first of all, let us comment this code, copy this code and comment this code. Let us paste our code, and then what we need to do is, we have our embeddings, or we have our document in docs, and then we have the embeddings in embeddings. So we need to specify docs, embeddings, and then client, table name, and query name. So let us run our code and let us see all the embeddings are stored in our Supabase database or not. So let us come to our terminal, clear it, node index dot. So now let us do one thing. One thing we need to do is that in our package.json, we need to add type equals to module so that we do not get warning in our terminal. And another thing what we need to do is, let us not store this in vector store, and let us not create a new instance. Instead, what we can do is, we can use method from documents, because we want to store document embeddings in our database. So we need to call from documents method. Let us save our file, come to our terminal, and then again run node index.js. So my terminal is opening. So okay, here is my terminal. Let us run node index.js. So it says vector store is not defined. It is because I have commented this code. Let us comment this code as well, and let us again run our index.js. So it says vector store is not defined. What is the error now? I don't see any error right now. I think this was not stored. Okay, in line 38. So okay, that was because it was not saved. Let us clear this and let us again run node index.js. So currently what it should do is that it should store all my embeddings in the vector database. So let us come to our Google Chrome. Let us go to our table editor, and then in documents we can see that embeddings has been stored. We can see content, which is in text format. We can see that this content was taken from line 1 to line 1. Okay, so this is from line 1, this is from line 1, this is from 3, and this is from 5. So we can see corresponding vector embeddings for each text. So until now, what we have done is we've created chunks, we've created embeddings, and then we have also stored those embeddings in our vector database. And we have also created retriever, but we have commented that out. So let us carry on with our retriever. So what we can do is we can actually comment this code, since we have already stored the embeddings in our database. We do not want to store same thing again and again. So I have commented this out. So let us uncomment this code. And now what we need to, okay, let us uncomment this code. Now what we need to do is, we've created our vector store. We have passed embedding, we have passed client and table name, query name, and we have our retriever, which will actually retrieve matching documents. So now what we need to do is we need to invoke this retriever. So let us come here and let us invoke our retriever. So I want to await, let us call our retriever and let us invoke and let us pass a query. So suppose I want to ask a question, what are my strengths based on this resume? So let us store this result in const retrieve docs. And what I want to do is this will give me documents. So what I want to do is I want to convert that documents into text format. So to convert that document into text format, so okay, first of all, let us see how the documents look like. So let me console.log retrieve docs. So let us save this and come to our terminal and run our index.js. So it might take a little bit time to retrieve the matching document. Okay, we can see that the matching documents has been extracted from our vector database, but currently you can see that our response is in the form of documents. So what I want to do is I want to convert these documents and get just the page content as a single text string. So to do that, what I want to do is I want my retrieve docs and let us map through each documents. And from each documents I want the page content, and let us join each page documents with \n, and let us store this in the variable context. So currently, what should my context be? It should be just a plain text string that answers these questions from the database. So let us again see how context looks like. Let us save this file, open the terminal, clear the terminal, node index.js. Let us make our terminal big. So this should now show me a plain text which answers my question. Okay, we can see this is a plain text. So currently everything is working fine. Now what we need to do in the next step is we have retrieved matching documents from VectorDB. Now we need to pass this to our LLM. So we haven't created our LLM, but I told you that the LLM that we'll be using is Google Gemini. So let us create our Gemini API instance. So new chat Google generative AI, and we need to pass certain configurations like API key. So we have stored our API key in env file. So let me access it. So env.gemini API key. Now another thing we need to pass is the model that we'll be using. In our case, we'll be using Gemini 1.5 Flash. And let us add temperature. So temperature would be 0.7. So let us store this instance in a variable called LLM. So we have created our Gemini AI instance. So now one main thing that we need to do is we need to create a prompt. So we need to pass certain prompt and the context to our LLM so that LLM can actually structure the response and display the result. So let us create a prompt. So prompt, and let us create the prompt using prompt template from LangChain, and we have a method called prompt template. Now what we want to do is we want to create a prompt. Let us use string literal and let us create a prompt. So I have created a prompt here. You can see that the prompt is, you are a helpful career coach. Based on the following resume context, give constructive feedback about the user's strength and what kinds of roles they are suited for. And we'll pass our resume context and we expect model to give feedback. So now what we want to do is we want to create our chain, because LangChain is all about chaining different components. So let us create our chain. And what we want to do is we want to pass our prompt to the LLM. So let us join using pipe method to our LLM. So what you're doing is we're passing our prompt to LLM, and then LLM will give some response which will be in document format. Again, what we need to do is we will convert that to string. So string output parser. So what we're doing is we're passing our prompt to LLM. LLM will give response, and then we're changing that response to string format. Now let us invoke our chain actually. So const result equals to await chain dot invoke, and what we need to pass to our chain is that we want to pass context, which we have in context variable. So let us pass context. So let us console.log result. So let us come to our terminal and let's see everything is working fine or not. So node index.js, let us run this. So we can see that we have received a structured response from Gemini. So the response we received is, let us come here. Okay, based on your resume, you are well suited for a range of senior level marketing roles, including but not limited to, we're well suited for senior marketing manager, director of marketing, head of digital marketing, marketing consultant. It also gave us areas for improvement. So quantify more achievements, expand on Madcom award, tailor your resume. By focusing on quantifiable results and tailoring your resume to specific job descriptions. Okay, so we're receiving structured response from Gemini. So let us again understand how we built our AI agent. So currently we have an AI agent that can read our resume and then can give feedback according to our prompt. So in this case, we are asking what our current strengths are. You can ask anything about your resume and this AI agent should be able to answer all your questions. So let us quickly revise how we did so. So first what we did was we created our resume.txt. We imported our text from resume text and stored it in the variable resume text. We created chunks and then we created embeddings. We stored those embeddings in the Supabase vector store, and then we created a retriever which would retrieve matching documents from the Supabase database. And what we did was we invoked that retriever with a certain query, and then the retriever would respond certain documents which we converted into plain text. We created our LLM, which was Gemini, and then we created a prompt where we pass context as the variable, and then we create a chain where we pass prompt to our LLM and we structure our LLM response into a text format. We invoke our chain and then pass the context that is from this variable. And finally, our Gemini responds a suitable message. So I hope you were able to understand how to build a RAG AI agent. In this case, we built a resume bot. But after watching this video, I hope you will be able to bring or build anything according to your use case and enhance your productivity and save a lot of time. Also, I'll provide you the code in the description and all the links to how to get the APIs and credentials. I'll provide that in the description. I'll also provide this Excalibur sketch in the description below. So if you like this code, if you like this tutorial, please do not forget to subscribe, like this video, and let me know in the comment section